You know that feeling, right? You slip on a pair of noise-canceling headphones, and the whole world just fades away. That constant drone of an airplane, the rumble of a train, it just vanishes. It honestly feels like magic. But it's not. It's an absolutely brilliant feat of engineering, and today we're going to pull back the curtain and see exactly how it works.
So the big question is, how is that even possible? I mean, how can a device you wear on your head take sound waves floating through the air and just eliminate them? It's not just blocking the noise like earmuffs, it's actively destroying it. How?
Well, the secret, and this is really the core of the whole thing, is a concept called anti-sound. You see, the headphones don't just put up a wall against noise, they fight fire with fire. Or to be more accurate, they fight sound with more sound.
So what in the world is anti-sound? Well, just think of it as a perfect mirror image of the unwanted noise. It's an evil twin, a sound wave that's engineered to be the exact opposite of the sound wave you don't want to hear.
The principle is actually surprisingly simple. You can think of it like basic math. If that annoying background hum is a +1, then your headphones created perfect -1. And what happens when you add +1 and -1 together? You get 0. You get silence. It's kind of elegant, right?
Okay, so here's how that whole process plays out in 3 simple steps. First, there's a tiny microphone on the outside of your headphones that's constantly listening to the world around you. Step 2, a super fast processor inside instantly analyzes that noise and creates the perfect -1, that anti-sound wave. And finally, the speaker inside your ear plays your music and this brand new anti-sound wave at the exact same time.
But to really get this, to have that aha moment, we need to quickly rethink what sound actually is. You know, we've all seen that classic picture of a sound wave, that little squiggly line on a graph. But the physical reality is a little different, and it's totally key to understanding how this all works.
So yeah, we usually see sound as that simple line on a graph, but that's just a representation, a drawing. In the real world, sound is physical. It's invisible ripples of air pressure moving through the air, almost like the waves you'd see in a pond.
So these ripples are made up of 2 parts. You have areas where the air molecules are all bunched together. That's a high-pressure zone. And then you have areas where they're spread really far apart. That's a low-pressure zone. And this chain of high and low pressure is what hits your eardrum, and your brain says, hey, that's sound.
And this is the real magic trick. This is the moment it all clicks. The headphones create an anti-sound wave where its low-pressure zone lines up perfectly with the noise's high-pressure zone. When they meet, they cancel each other out, right? You're left with just neutral air pressure. And what does neutral air pressure sound like? Nothing. It's silence.
Okay, so the physics is pretty cool. But turning that elegant theory into a tiny, lightweight device that fits on your head, well, that presented some absolutely massive engineering challenges.
Specifically, the engineers had to solve 3 really big problems. First, how do you measure the noise accurately? Second, how do you time that anti-sound wave perfectly? And third, how do you mix it all together with your music so seamlessly that you don't even notice?
So first up, measuring the noise. Here's something you might not know. Your headphones already block some sound just by being on your head. So there's a mic on the outside listening to the world, sure, but there's another one on the inside that's checking what noise is actually leaking through to your ear. That second mic is basically quality control, constantly checking to make sure the cancellation is working right.
The second challenge, and this one is huge, is timing. That anti-sound wave has to be created and played with just mind-boggling speed and precision. We're talking about milliseconds. If it's off by even a tiny fraction of a second, the whole thing fails. This is where a really powerful, super fast digital processor becomes the hero of the whole story.
And finally, that processor has to perform one last bit of wizardry. It takes the anti-sound wave it just created and digitally adds it to the sound wave of your music or your podcast. The 2 signals become one single combined signal. That's what gets played through the speaker. The result? The anti-sound part cancels the outside noise, and you're left hearing only what you wanted to listen to.
So if this technology is so darn clever, why isn't it perfect? You know what I mean? Why can you still sometimes hear things like people talking nearby, even with the best headphones money can buy?
Just think about your own experience with them. Active noise cancellation is absolutely amazing at killing that constant low hum of a jet engine. But it's not nearly as good at blocking out, say, a sudden clap or a nearby conversation. So, what's the deal?
It all comes back to that challenge of timing and prediction. See, a low-frequency drone, like an engine, is very simple and repetitive. It has maybe a few hundred predictable pressure waves every second. But a high-frequency sound, like human speech, that has thousands of complex, totally unpredictable waves per second.
So here's the bottom line. It's actually pretty easy for that little processor to predict and counter a simple repeating wave. But trying to create a perfect anti-sound wave for the thousands of complicated, always changing waves in speech and do it in real time, that's just beyond what our current technology can do perfectly.
So there you have it. Noise cancellation isn't some kind of black magic. It's the incredible science of anti-sound, of creating a perfect opposite to neutralize pressure waves right before they reach your ear. Knowing that, it kind of makes you wonder, what other invisible technologies are all around us, working in ways we can't even see?